Hey everyone, thanks for joining the talk today. The topic for today's talk is about a multi-layered approach. I call it the security onion approach towards securing IAM roles. So just before we dive into the topic, a quick introduction about me. So right now I'm a security engineer at Lyft, and I work on application and cloud security projects. You can definitely follow me at Narayan Gowraj, which is my first name and last name. So the topic, the agenda for today is we're going to talk about IAM roles. I wouldn't be talking much about the introduction of IAM roles, what IAM roles are, but why did we choose IAM roles among the other IAM principles? A little bit about the ETL process, like how we enumerated fine-grained details about our IAM roles in our AWS infrastructure, the plan of action, and how did we measure success, whether this particular initiative was successful or not, and a little bit about the automation that we did and the key takeaways that we had, and also for the listeners, and then I can open it out for a Q&A session. So, why are we talking about iron roles today? So, IAM roles, as you guys might already be aware, it's an entity that defines a set of permissions which are granted through IAM policies for accessing AWS resources. The reason why I've chosen IAM roles among the other IAM principles is because of the fact that we use IAM roles extensively for both services and humans, and we differ away from IAM users for the reason of IAM roles being short-lived. You don't have to worry much about credential rotations. And then we also actively use IAM roles. We attach them to a single sign-on system so that we can have like federated users, in which way we can like have fine-grained RBACs, and as well as we can make sure that we follow least privilege access for users by attaching them to like specific groups. And it's permissions oriented. So if in case we need a bunch of users to get like additional permissions, or if in case we want to decrease the permissions that they have today, we can tune our IAM policies so that they if they want like more permissions or lesser permissions. And also we tend to use IAM roles for cross-account access, and in the form of trusted entities, where we define who can assume an IAM role, and if it is a cross-account access within the organization, we tend to use IAM roles for that rather than an IAM user, which might be too much to manage in terms of like credential rotations and credential management. So a little bit about the ETL process. So the main goal of this talk is about uh, the main goal of this initiative is to have the right amount of data towards our IAM roles so that we can like make very informed decisions. So for the process of ETL, we leverage two important tools. One is the Access Advisor APIs that AWS offers, and also a tool called Cartography. I'll talk about these specific tools in my next slide. So these are the two important tools that we leverage to provide the right amount of data to make informed decisions. So talking about Access Advisor API, so we used Access Advisor APIs to analyze permissions that an IAM role has, uh, basically for providing like guardrails to make sure that we follow least privilege access. We don't have overly permissive IAM roles. So we used Access Advisor APIs for that, and also we wanted to kind of analyze the usage details of it. So when I say usage details, I'm talking about like what AWS services an IAM role can access, and what are the AWS services that the IAM role was used in the past to access, or what are the services that are not used currently. So by using Access Advisor APIs, we differentiated the used versus unused services for a particular IAM role, and we wanted kind of a relative term rather than like just an empirical number. So we compared that with the total number of AWS resources, and from my research, it seems to be like 212 like unique AWS services or services that AWS offers. By using that, we had like we got data from Access Advisor API and the table schema, where we had like fields like last activity. We also analyzed what are the different trust relationship a particular IAM role has, and also we compared the number of services versus the number of unused services, and also we had like a list of services and unused services, so that we can use that in the future to kind of like make more formal and informed decisions. So now going to cartography, which was another tool which was very helpful for our ETL process. So for people who don't know what cartography is, so cartography is an open source tool. It's a Python tool. It basically consolidates infrastructure assets and provides relationships between them in a very intuitive graphical manner. It uses Neo4j, which is a graph database. It's an open source tool, and it was created by engineers at Lyft. So you can, and it uses a query language called Cypher, which is what is used to query the data that the cartography has to kind of like understand the mapping between assets, and also the relationships that exist between assets within our AWS infrastructure. So people might be curious of why we wanted to use cartography. So we wanted to use cartography for IAM roles to get even more finer details about a particular IAM role. In the sense, for example, who can assume an IAM role? Like, can a service assume an IAM role, or is it like only humans can assume, or is it like both? So we wanted to kind of like get those level of details when it comes to assuming an IAM role. So we used cartography for that. And also, we wanted to understand the relationship that exists, or what privileges can an IAM role give a user or a service. Can it access data stores like S3, DynamoDBs, and can what level of permissions it gives you? Like, for example, can it only query a DynamoDB table, or can it like read and write, or like versus like an admin level permissions, where it can like delete a particular DynamoDB table if somebody can assume that IAM role. So these were some of the details that we got, and we also used internal configuration files to kind of identify DynamoDB tables and as well as S3 buckets with PI data. So we also used that data to analyze our IAM role. So for example, if an IAM role can access a bucket with a bucket which has been labeled for PI data, then we know that if somebody can assume this role, then they can access a bucket with PI data, which might be something that we should be aware of. So after we get all, so we got this data from access advisors and as well as cartography. So why did we go with the data from cartography? So we wanted to have a risk prioritization or a risk-driven approach. So we wanted to understand what is the risk of a particular IAM role being compromised. Like, how can it be compromised, and if in case it gets compromised, we wanted to kind of like understand the impact of it. So we used a very simple risk assessment matrix where we just calculated impact into likelihood for a particular IAM role. And as you know, the data that we got from cartography was very helpful to kind of like label a particular IAM role, or label a particular IAM role's risk. So for example, if an IAM role has access to S3 buckets and DynamoDB tables, then we know that this particular IAM role, I mean, if it gets compromised, then the impact is we have the label. I mean, we have the impact to be very high. So when it can only access S3 buckets, we bump it down. I mean, we bring it down a little bit too high. So we kind of like use these kind of like rules and signatures within our system to do risk prioritization or risk rank a particular IAM role. And the cartography data was very helpful for this. We did the same for likelihood. For example, if humans can assume a particular role, I mean, in that case, we mark it as like likely to get compromised, because people can use them or in a local script like which sits on the machine, or they could like spin up a lambda. It can sit there. So we wanted to kind of understand that like kind of differentiation, if humans can assume it, or if service can assume it, or if both can do it. So we did this data. We processed all this data, risk ranked up every IAM role, which was very helpful for our for future editions. And also we we wanted to have this data. We wanted to utilize this rich data sets for other purposes as well, which was very useful for security incidents, where if a particular IAM role gets compromised and we know about it, it was very helpful to understand what was the blast radius. Was can it can if it was you if it could be used to access S3 buckets with PI data, we could do that. We could use that for root cause analysis and postmortem. So it was very helpful to contain and recover. And also in an organization where we heavily use IAM roles and for not just services and productions, but also like other smaller scripts and like cron jobs, scheduler jobs. We wanted to have the difference. We wanted to know which teams or which, when we wanted to know what IAM roles can do, and so that that can be matched and notified teams, or like we can page teams or notify them about a particular incident, so that we can make very quick decisions and also the right decisions when it comes to like security incidents. So right now we have the ETL process in place. We have the rich data set in a SQL DB. So we wanted to use these data to kind of like have our plan of action was to have like three different milestones where we wanted to remove the unused roles based on the data that we have. We also wanted to limit the permissions of a particular IAM role, if that particular IAM role is being used actively, but not all services are being are used on a very regular basis, then we want to kind of like limit those permissions. And the foremost was also to define like detection alerts. So like once you know that you have done some cleaning process, we wanted to have some detection alerts because we now know what a particular IAM role can give you access to. We wanted to have some kind of drift detection. Let's say if an IAM role was being used to access S3, but now it's also being used to access DynamoDB, we wanted to kind of identify those at scale within the infrastructure to kind of like have those drift detections. So so to start with, so removing unused roles. So removing unused roles was pretty straightforward, where we already had the data for last activity, and we also had a threshold of 180 days. So if the last activity is -1, which basically says this role was never being used at all, or if the role was never used in the last 180 days, we kind of like knew that this role was never used to access any of the AWS resources, and we were able to kind of like identify those IAM roles from the SQL query. And also, as you can see, the risk score was very helpful for us to kind of like do it in like in a multi-stage approach, like phase it out, like do like phase one where we prioritize and risk scores, or like IAM roles with a risk score of like really high risk scores, do it, and then like see what the results are, and then like maybe go to the next ones like based on the risk scores. So next thing was limiting permissions. So our SQL database, or the data that we collected, also had the percentage, like when a particular IAM role is being used to access 10 different services, and if that particular unused service percentage is more than 75, because we always take like relative terms, not just an empirical number. So we wanted to use that to kind of define IAM roles with a service percentage of more than 75. And also your risk score again like is super helpful for us to like prioritize which roles should be like first taken care of. And also, since we have like this entire list of unused services, this is where it kind of like got a little challenging for us, where an IAM role could have like this overly permissive access because of IAM policies that could be like inline policies or AWS managed policies or customer managed policies. So in those cases, we had to like identify and analyze those policies that are attached to an IAM roles, and then we either removed certain policies, or we removed all the policies and just like attached an inline policy if in case it just uses like couple of services, and but whereas it has like access to more than like 50 services. So for example, so we used that data, the list, to kind of like define those like right permissions for a particular IAM role. So the next part is about detection alerts. So now so now we did the cleaning process. So now we wanted to have some kind of detection alerts. So we had like multiple detection alerts. I'm going to like talk about two detection alerts that were super helpful for us. One is to have an alert for privileged roles. So privileged roles in the sense that if a role can be used to access more than 75 services within of AWS that AWS offers, which is the 212 number that I pointed out, and if the score is red, then these are very high privileged roles. If in case it gets compromised, that it could be very detrimental to the business. So we enable MFA alerts for that. The second example would be we know that an IAM role can only be used from an EC2 instance because it's attached to an instance profile. So since we had that kind of like finer details, we wanted to kind of understand if an IAM role is not accessible, it cannot be assumed by humans, but can be assumed by just EC2. And if that particular IAM role is used outside of like a particular CEDAR block of IPs, then we wanted to kind of like notify about that. So we wanted to have like these kind of detection alerts in our infrastructure. Uh, and so we also wanted to kind of like define high level KPIs to kind of like understand whether this experiment was successful or not. So the three important KPIs that we had was IAM roles, number of IAM roles deleted. And since we had the unused service percentage, we took an average before versus after the experiment. And the third thing was how many drift detection alerts that we created and what are the actionable items. So when we have a detection alert, we wanted some kind of actionable items from it. If not, it's going to be just like laying around there. So we wanted to calculate the number of drift detection alerts and actionable items coming out from it. It's a simple automation. It's a cron job, runs on a regular cadence, talks to AWS Access Advisory API and Cartography, gets the data that it needs, massages it, puts it into MySQL DB, and then we have different custom integrations that we have. Slack bots, we could have Slack bots, we could have like pages if in case we know that we know that this particular incident should not have occur, or we with high level of degree confidence. If you have that, then probably then use like a pager duty for that. But we also used a lot of SQL queries from like different direction pipelines to kind of like query this database because it's up to date. We wanted to query this database to identify drift elections, to make like more informations in the first place. So the key takeaways for us from this project, and also for the listeners, so we identify that a risk-based approach kind of like delivers a lot of value because we are able to kind of like break it down into separate silos, not just like provide a list of unused roles. So a risk-based approach was very, very helpful. And also rich data sets from cartography and as well as access advisory APIs. We also used PMapper, Principal Mapper instead of cartography for some time. So having these rich data sets helps us make very useful and informed decisions, which were like very helpful. And also the other key takeaway was continuous monitoring leads to positive trends. We wanted to have not just have a particular system which does this on a one-off basis. We wanted to have something that runs on a regular cadence, so that we know if something goes bad, and so that we can make very informed decisions and as well as take decisions as soon as possible. Because we wanted to identify drift detection alerts, and also we wanted to identify bad IAM roles, like bad in the sense it was never used or it has like overly permissive access. We wanted to identify those at an early stage so that we would be able to uh, either kill them, or we might be able to kind of like define permissions. We might be able to define permissions for them. Well, I mean like list privilege permissions for them. So yeah, this is a talk. I'm going to open it up for questions, and I've also shared the feedback form here. This is my first talk at CloudTech, so I would definitely appreciate if there are any feedback on the talk, content. So yeah, feel free to do that. Thank you, everyone.
Thanks, Narayan. I think the most interesting discussion on the Slack was about the uh, how you do the risk management, how you define the impact and likelihood of given risks. And so, a question from Fernando of a given role, and a question from Fernando was whether you'd put any thought into using quantitative risk management, using things such as number of records protected or statistical anomalies to quantify the impact or likelihood of a role compromise.
Sure. So it depends on like the data that we had. Like for example, for S3 and DynamoDB tables, we had like very finer level details for an IAM role, like in the sense that can it just like query a DynamoDB table or can it write read versus write? So we use those kind of like data, but at the same time, we kind of like mapped what an IAM role can do. If an IAM role can access, let's say KMS, then we, and in our case, like KMS accessing an IAM role accessing KMS was very critical for our business. So in those cases, we kind of like had those kind of like different rules to assess the impact, and also likelihood was more on like who can assume an IAM role. Can any user in the user account or the AWS account can assume the IAM role? So in that case, if it is not protected with an MFA, then we kind of like use those kind of like finer details to define likelihood and impact.
A related question from Joel was, how do you think about role chaining? So if a human can assume role A and then role A can assume role B, is that something you'd look at or consider in the scoring?
That's a good question. So we definitely thought about it, but in this case, since we are talking very granular about like but individual IAM roles, we thought about it, but we didn't come across like scenarios where um, since we are like permission right sizing for like every role, like we kind of like had our focus towards like individual IAM roles. But yeah, I mean, like I definitely, I think role chaining definitely makes sense, and that should be definitely taken into consideration as well.
Great. A question from Abdul around the data sources that you use. He notes that Access Advisor provides service level usage. Do you also look at or find value in API level, like specific action level usage details?
Uh, yeah, so the usage of Access Advisor in our case was like service level details. We haven't looked into like the API level details for that.
And one other question, which you highlighted, uh, you highlighted using a KPI of what fraction of permissions that the role is granted that were used as one of the ways you determine success. What about the alternative? Do you look at number of access denied or any issues that you get in CloudTrail as a way of determining whether you're managing your roles correctly?
Um, Yeah, that's a good point. I think I can definitely take that and see if we can add that as a KPI. But yeah, so since we had the data of like the average users or the average unused for an IAM role, so we wanted to get that. We wanted to use that to kind of like consolidate everything together and do an average. But I think that's a good point. Like I'll definitely consider that. I'll definitely take that into account as a KPI as well.
Oh, very cool. This is great work. So thanks so much for presenting. We will be back in about 5 minutes with Rich Mogul. Please leave your feedback. Thank you very much, Narayan.
Thank you.